Okay, we shall get started. The best slot of the conference, the last slot of the day, on the last day of the conference, where everybody's fresh, minds are clear, raring to go home. I thought I'd give a talk about something that is really passionate to me. This is not going to be a technical talk. We've got some code that we're going to talk about, but really this is an idea about how we write better software. So before I get started, I want to talk a little bit about the motivations of why I built this talk. Because as it stands at the moment, I currently work for a company called Honeycomb. We're a telemetry company. We write a backend for open telemetry where we can send telemetry data, which helps you understand your production systems. Before that, I was an independent consultant. I used to go around organizations talking and evangelizing about how we write better software that lives in a production environment, how we make it easier for engineers to understand what's going on. And basically, that starts by writing better software. But you can't just walk into an organization and go, write better software, here's a bill for 10,000 euros. You have to give some context. So I was brought into a credit lender in the UK with a few other consultants. And what they wanted to do was build a brand new core banking back-end system. And if you don't know, the banking sector is run by COBOL. It's run by mainframe servers that live in a big data center somewhere. They're not really modern software. They wanted to build something brand new, something from scratch. And they gave us a developer's dream, which was go and build it the way you want. So we set out by trying to understand what we wanted to build, how we wanted to build it more specifically, and started from scratch. We took a lot of principles that exist today, things like TDD and various other techniques, and decided to start building them as a process together. And that's what we did. We started building a bank from scratch. What I'm about to show you, the methodology, the things that we were thinking about, is not theory. It's not me coming up here and going, it'd be great, go and try it. Tell me if it works. This does work. It is used in production on a high-volume credit lending platform in the UK. I can't talk about exactly what it is, but yeah, it is used as a backend. It is useful, and I hope that it is something that you find useful. So we're going to talk a little bit about what I call operable software, what the term means to me, because words are meaningless, we give them meaning. We're going to talk about how we as engineers test software. We're going to talk a little bit about what outside-in testing is. And then we're going to talk about, well, I work for an observability company, so we're going to talk about how observability keys in, which was a core part of why we built what we built at the time. Whether that is the reason why I now work at Honeycomb, I don't know. But okay, so let's start by defining what I mean by operable software. And I mean software that is built for production. Because I don't know whether you know this, but nobody cares about any other environment than production. No CEO is going to turn around to you and say, I know we lost £20 million because production went down, but I'm really happy that it works in your development environment, and I'm really happy that staging's still up. Nobody's going to say that. Production is the only environment that matters. Everything else is pointless. We use it to get to production. The goal is production. So when we're building software for production, what we mean is software that is built to run in a production environment. It's built to run in an environment where the database is not on your machine. It's built to run in an environment where Service Bus is what you use as your messaging platform, not RabbitMQ locally, because there was no... When I originally did this talk, I was able to go, there's no emulator for Service Bus. There's an emulator for Service Bus now. Ruined my talk, Microsoft, thank you. But it's built to run in a production environment with production-grade systems. It's built with the live operations team in mind. It's built in a way that allows us to know what's going on in production, to know how it's functioning. Is it doing the right thing? Is it going fast enough? Is it throwing errors? We're building it so that we know what happens in production. I don't care about the stream of text that comes off your console that makes you feel good because it feels like you're actually doing something. I care about whether I know what's going on in production. Live operations, that might be you, as you building the platform and you running the platform, or it might be a separate team. But it's built with that team that runs it in production in mind. It's built for things like fast recoverability, MTTR, mean time to recovery, that kind of stuff. It's built in a way that allows us to be able to recover from failure. That might be just restarting a service, but it also might be finding out why it went wrong and fixing it. All of that leans into this idea that we need to build systems that emit robust telemetry signals. This isn't a pure talk about just add open telemetry. That's not what I'm saying. But do that, and then send it to Honeycomb. It's great. But it is about thinking about when you write software, how do we know whether it's going right? But also, how do we know what is right? But also, what do we mean when we talk about software? We have a very narrow view, a lot of people, around what software is. Software is the code I write and I commit to GitHub. That is pretty much what software is, but it's not. It's everything. It's the application, the code that users use. It's the tests that you write. It's the build pipelines, the deployment pipelines. It's the infrastructure that hosts it. And it's the observability tooling that allows you to know what's going on. That entire stack, that is software. Because without a single point of that, if one of those doesn't work, users cannot use your platform and you cannot fix that platform when it goes wrong. Together, that is what we mean by software. So let's talk a little bit about testing. And we're specifically going to talk about TDD. Because TDD is... Now, I've done this talk a few times. It's been on YouTube. There's quite a lot of people who have responded to that post going, he doesn't understand the difference between unit testing and integration testing and component testing and end-to-end. Believe me, I know those words are meaningless. And it's because they've been used by different people to mean different things over so much time. And TDD is the same thing. Now, if you go back to what we really meant when we started talking about TDD, it was contract first. We define a contract, a behavior that a system or a service or a class or a method is going to do. That's what we define first. We write a test. That's what we mean. We then make that test pass by writing some code, and then we're able to refactor. The key thing is we write the test first before the implementation because it defines the behavior we're expecting. That is the core of what TDD is. The problem is it's commonly misunderstood as mock all the things. And I can do that in a .NET environment because everybody gets the joke. You do that in Java conference, they don't get it. But it means that they end up with a single class with 17 dependencies and mock object everywhere. And it's the idea that what they're actually doing is they're testing a single method. They're testing one method calls another method. Great, good for you, makes you feel good. 4,000 tests on that class? Great. I get that you feel really good about those 4,000 tests. I'm with you. Nobody cares. Because nobody cares about individual classes. Nobody uses those individual classes. What they use is your system. That's what we care about. So why is it that we actually think TDD is a good thing? Why is it that we actually start pushing TDD on every junior developer that comes in and we tell them to test every property on every class? Why? Well, we think it improves the design of contracts, and that is the main reason why TDD is so good. Because it allows us to be able to define behavior by defining what we expect the thing to do by what we give it. It allows us to refine those contracts and define those contracts. It might be a method contract, it might be an API contract, but it allows us to help define that contract. It helps us understand our code base by saying we're asking a class to do a thing. It's not we're calling a method and making sure it calls another method. We're asking a class to do a thing. We're asking an API to do a thing and then verifying the thing was done. But it also allows us to have documentation, because if we actually write things in a TDD way, What we're actually doing is we're defining the behavior by saying, I would like it to do this thing. And when it does that thing, we know if I pass these parameters to this thing, it does a thing. That's documentation. It allows new developers to come and look at the tests and understand what's going on. That's the good. But what about bad? What's bad about TDD? Why wouldn't we do it? Well, most of the time when people do TDD, they do it in the absence of the people who use the thing that you are trying to test. So if you're writing a method and you're testing a method, you don't care that actually it's used 17 layers above you in an API. You just care about your one class. And the reality is that doesn't matter. What your individual class does doesn't matter. What matters is what the users see. So when we write these tests, we're writing them with the absence of those external consumers. And because we write them too low, they end up being brittle. They end up making our software development flow brittle. Because as soon as we change the behavior of that thing down right at the bottom, we've now got to change the behavior of every single test above it, which means that now we've got one small change at the bottom that's changed our code. And if we change our code and we have to change our tests, we can no longer trust our tests. And if we can't trust our tests, how are we going to deploy? Now, one of the things that we did when we did this at the credit lender that I was working with, we had one team who did this. They had 4,000 tests written from the outside of their application at an API level, just testing the behavior. And what's really interesting, they worked out that the internal model, and this is pre-production really, but there was lots of people using it internally. And they had about 4,000 tests. They decided that the internal data model was wrong. The way that they stored the data, we were event sourcing all of this, the way they stored the data was wrong. So they had to go and rewrite a significant portion of the internals. And they did that. And all 4,000 tests passed. And then they spent 3 days saying, I can't deploy it. I'm like, what do you mean? Oh, your tests are passing. I'm like, well, we didn't have to change any of the tests. We just changed the thing under the hood. The tests haven't changed. How do we know that that thing works? Well, one of two things is happening here. Either you never trusted your tests, or you should just deploy, because everything passes. And I think that's a real big indicator of where we sit in software development nowadays. Because if we've defined all of the behavior, and those 4,000 tests that run in 10 seconds, if all of those pass, just deploy it. Because either you never trusted the test in the first place, or the system is okay. If we write the test too low, we end up changing too many things, and then we don't trust the tests, so we feel like we have to do additional testing. We feel like we have to get humans to come and intervene. But if you never trusted your test in the first place, that's right. So I want to talk a little bit about component testing. And this is normally the point in the presentation on YouTube where I get all the comments that come up and go, oh, no, he doesn't understand the difference between unit and integration testing. Because what we're going to talk about could be construed as integration testing. It could be construed as component testing. It could be construed as any kind of name that you want. So I'm going to call it component testing because there's not many people who use that term, so nobody can say I'm wrong. I love this meme. Because it directly tells you what's happening in modern code bases today. People write the tests so low level, that drawer opens perfectly fine. In the warehouse, we put it all together, it works absolutely fine. It works absolutely fine. We put them together and go, oh, we might have a problem. Did everybody think of putting these like two classes in the same API and then testing it before we finished writing the 4,000 tests? No. Okay, well, those 4,000 tests are now useless. You're going to have to write some more. But what we're going to talk about is component testing or outside-in testing. Because the reality is what we're actually reaching for is feedback loops, always. Who here has read the book on extreme programming? Anybody understand what XP or extreme programming is? God, I know I feel old. So extreme programming, some might argue it's the precursor to agile, whatever that means. But ultimately, it was all about how do we write better software faster? Well, we get faster feedback loops. We want to bring people closer. We want to see what's happening in our systems sooner so we can fix them and we can move faster. Now, if you really think about it, the fastest feedback we have is our linter. That might be a code formatter in .NET. It might be the squigglies that you get under stuff in .NET. In a compiled code base, it's a little bit easier because you've got the compiler that will tell you that you can't call that thing with an integer. It expects a string. In TypeScript, well, in JavaScript, well, good luck. But in compiled languages, you've got the compiler. Now, these are all the time it takes for you to get feedback. The further out we go, the longer it takes us to get feedback. The next stage would be developer tests. Again, I'm using a term that most people don't use, so I can't be wrong. Developer tests. Tests that we write against a class, tests that we write against a method, tests that we use the web application factory for. The tests that a developer writes and runs locally. It's faster that way. We'd have to push it up to GitHub and wait 4 hours for a build pipeline to kick in. We've then got end-to-end tests, things that are in a deployed environment. We have to wait because it has to wait for the messages to go through the message bus, that kind of thing. We've then got our production telemetry, which is a feedback loop that's going to tell us whether the system is running. And then we have the OG feedback loop, which is customer complaints. Your email inbox is a feedback loop. What we want to do is we want to move, God forbid, we want to shift our feedback to the left. We want to get as close to us as possible. That's what we're looking for. When we write software, we want to get that feedback as early as possible. And we want to bring all of that, we want to get all the stuff that the customers might complain about, but we want it sooner. How do we do that? How do we get our production telemetry, our end-to-end tests, our customer complaints, all the way to the left? And that is where we start thinking about outside-in testing. So outside-in testing is really working from our external consumers. Those are the things that matter. They're the things that the people who are going to use our class, our API contract. Now, if we're using a HTTP API, that might be the endpoint. If we're writing an inner-sourced library for other teams to use, the external consumers are the other teams that are going to use it. They'll be using your actual class from your NuGet package. Doesn't matter. What we're doing is we're thinking about those levels that we're testing. We're testing the inputs and outputs. If somebody needs to get data into an API in order to be able to get data out, we're going to push the data in via the API, and then we're going to get the data out by the API. Which means that we're testing from a user's perspective. And we're testing the business requirements. Now, what it also means is that we're testing our business requirements first. That's the thing that matters. We're writing tests that test our business requirements. Now, when we started doing this particular project, they brought in a lot of legacy BAs. Awesome people, really, really nice people. But they'd been working in the banking sector for a very, very long time. And their business requirements were, it must have a database. That's not a business requirement. It must have a table that has transaction ID. No, that's not a business requirement. So we got to train them on how to be talking to us about what the business requirement was. And they would say, well, it needs to create a transaction. It's like, great, okay, I can create something that creates a transaction. I need to be able to get a transaction. Great, okay, I can start writing tests about these. Now, we went through a phase, it's about a 2-year project. Went through a phase of about 6 months, where I'm a pedantic guy. Anybody who knows me will be able to attest to that. I love being pedantic. So we went through about 6 months, and they came to us and said, there's a bug. Like, really? Okay. Let me know what the bug is. And they said, well, if somebody puts €1,000 in their account, and they try and spend 1,200 euros, it doesn't error. I'm like, oh, yeah, that sounds like a bug. That sounds like something the system would do. Can you, give us the reference for the requirement so we can put that in the bug? It's like, oh, we didn't put a requirement for that. That's just what it should do. I was like, well, I'm not going to build it if you don't give me a requirement, because I'm doing TDD. You give me a requirement, I write a test. I write a test, I write the implementation. If there's no requirement, there's no test. If there's no test, there's no implementation. And they're like, but you mean I need to write down everything the system needs to do? I'm like, yes. It's almost like that's your job. Eventually, we built a relationship, and they started to understand that it was really, really important that they define what it does. They define the error message they're expecting. They define the behavior that happens. Do they want that to go into an audit log? When somebody tries to spend more, is that important? Because I'm not going to put it in an audit log unless they tell me to. I don't know banking. That was the reason why we were brought in. I know modern software development. I know building software for production. I don't know banking. We have the burden of knowledge a lot of time. If you go into building an e-com site, you know how e-com works. You're going to bring your own preconceptions, and you're going to build things that is not required. Now, the other thing that happens when you start writing these things from a business requirements perspective is you end up getting into this idea of building tests that are actually readable. I don't know whether you've heard the term that code should read like prose. Your class should read like a Shakespearean novel. But ultimately, what we end up doing is we end up writing our code, our coded tests, in a readable way, because the language that we're using is business language. What ends up happening is we're testing the application holistically every time. What happens when we test in a unit test? The first thing we do is I'm going to mock the repository, and I'm going to add stuff to the database. Now, if you're allowing your customers, your card holders who are spending money, if you're giving them SQL Server Management Studio access to insert stuff into the database, I'd like to talk about your business processes, because I don't think that's the right way. What they actually do is they do transactions, and they spend money. So we're testing it holistically. We end up not having to create tons of mocks, tons of stubs. But my personal favorite is 100% code coverage. Code coverage is a vanity metric. Do not measure it. But if somebody's going to measure it for me, I am damn well going to hit 100%. Because what happens is, if you've got a bit of code that is not hit by a test, one of two things has happened. You have wrote code that is pointless. Or you have not written a test that should have been written. Because there's a requirement that you were told about and you wrote some code for it, but you didn't write the test for the requirement. So either delete the code or write the test talking to the BAs about why that exists. You hit 100%. It's great. So I want to talk a little bit about readable tests. Because when we take TDD as meaning just I write a test for a class, and I write another test for a class, and I write another test for a class, we're losing a ton of benefit. What TDD allows us to do is, because we're trying to define a behavior, we should be able to articulate what that behavior is. And we do that by using test names, descriptions. We write a descriptive test name that says, this is the behavior I'm expecting. We then write things like reusable actions. In the banking context, we write a reusable action that says, create a transaction for this amount. Which means all of our tests just say, create a transaction, spend some money, get a refund, complain to the manager. We write these things in there so it makes sense. We write things like abstract implementations of things that allow us to be able to build these tests up over time. When we're writing a new test, we've got a library of things. We're developers. But I see so many people when they're writing tests reinvent the wheel in every single test. There is no reason why you cannot refactor and abstract things in tests. Give them descriptive names. Work on those. Build an actual code base for testing your API. We end up using things like domain language, the language of the business, because we're testing things from a business requirements perspective, because we're sitting at the outside when we're writing this. We're not using the technical language. Nobody cares that the transaction service class calls a cache. They don't care. They care that it runs fast. But we end up using domain language for these things. What we end up doing as well is writing more tests. We don't end up doing verify object and having a test that tests the entire object like this. We end up with a test that says, I expect these 5 properties to come back, and another test that expects these 5 properties to come back, because we've had to describe it. We've had to describe why that portion of the request exists, because we built it up over time. Now, you may be coming to me, Martin, this is just BDD. You are right. BDD and TDD are amazing together. What we're doing is we're defining the behavior because the business requirements have defined the behavior. We're using that to drive how we develop, what we develop. That is BDD. To do BDD, you do not need Gherkin syntax. Speaking to people who advocated for BDD back in the day, they are really, really sad that it ended up being given when then. That was never what it was meant to be. It was meant to be about defining behavior and allowing that to be able to allow you to be able to build better software. So let's have a look at a little bit of code. Has everybody heard of the Web Application Factory in .NET? A few people that haven't. So the Web Application Factory allows you to be able to run an API in memory. So you're essentially newing up your entire API and allows you to be able to hit it in memory. Now, what we're not doing here is we're not going over the network. There's no go out of your application, listen on a port, and then hit that API. It runs all in memory. And that's the reason why this thing works. If we had to go out and back in, it wouldn't work fast. As soon as you start hitting an API, you're adding milliseconds on. If you think I've got 8,000 tests, and those 8,000 tests are making maybe 10 API calls, some of them, all of a sudden we're at like 20 minutes, 30 minutes, 40 minutes for these tests to run. Because it's running in memory, we don't have that. We've got millisecond time from hitting APIs. So what this code is doing is we're going to new up a new version of the API. We're going to create a HTTP client that we can use to hit that API in memory. What it does is it creates a HTTP handler that goes in memory to your API. We're then going to use that to hit the endpoint, and then we're going to run an assert. Now, this is very similar to the thing that I built on the first day when the BA team said we needed to create a transaction. Because the simplest way to make this thing pass, TDD, right, the simplest thing, is to write an API that accepts anything you want and returns 200 OK. Because they said, well, we need it to accept a transaction. I said, great. So we created this. We build the build pipelines, threw it up on Azure, and they hit the API, and they went, great. It takes the object I was expecting. I didn't care what the object was. I just returned 200 OK. And they were like, that's amazing. That was so fast. It's like, what's the API for getting it? I was like, whoa, that's a different requirement. And they went, oh, right, so we need an API for getting it. It's like, now we need a database. Because what we were doing is we were building it up from business requirements, and that allowed us to only build the things that we needed. So we first built something like this. Then we start to think about how do we make this a little bit more readable so that BAs could do it. BAs could read it. So the first thing we do is remove the implementation. We don't need to know that there is a web application factory when we're writing these tests. We don't even need to know there's a HTTP client in play. Because when you look at the test, what you need to know is I'm going to hit the API and I'm going to post some JSON to it. And I'm going to expect this thing on the back. But we can go a step further. And yes, I realize I am code golfing 4 lines of code. I'm good at code gonf when it's 4 lines of code. Then we move into something called AAA, which is arrange, act, assert. Very, very standard, very readable by a lot of people. And that's important because individuals do not build software. Teams build software. The unit of delivery of software is a team, not an individual. Everybody needs to be able to understand this. What we do is we move to this idea that we've got, well, we do an arrange, we create a to-do item, we hit the API, great. Then we could add some context. And this is where we get into this idea that it's really valuable when we're writing tests to really think about what we mean. What's important for that test? If I'm reading this, if I'm coming back to this 6 months later to understand what that is, do I need to know that a valid to-do item has a title and a description? Is that the minimum viable things that it needs to be valid? I don't care. Because if you look at that test, adding a to-do item with a valid request returns OK. The simple test. That does exactly what it said on the tin. Get a valid to-do item, throw that to-do item at the API, make sure it returns OK. If there is things that you read in that test that do not make sense for the scenario that you've described, then you are doing it wrong. Principle of least surprise. You shouldn't go into a test and then go, oh, but it actually goes over to service bus, and then it calls me mum. Why? So we can use the whole framework that we've got at our fingertips. We've got C#, we've got .NET, we can do loads of things. You spend so much time as engineers writing code that you're so proud of. Why don't we apply that to tests? Write tests that we're proud of. Write tests that other people can understand. Now, when we got to writing tests like this, the BAs came to us. And it was one of the most surreal moments that I had while I was working there. Because the BAs came to us like, can you come and demo this? I'm like, yeah, I can demo the test and show you the test. It's like, yeah, who to? The board. Like, excuse me? It's like, well, they can understand them, and it's going to show them why you can actually move faster than everyone else in the organization because you're writing tests at this level. Surreal, because they could read it. We were using their language to write these tests. We were writing abstractions. Our code was reading like prose. It was reading like a business requirements document, each one of them. They could understand it. They felt confidence that this system was working. Now, the next thing comes up is like, well, we could just add a few more asserts onto the bottom of there, and that's the floodgates. It's like, oh, I could just add one more assert. Just one more, and maybe another one. And now I've got 6. So 7's nothing, really, is it? Now I've got 50. Well, what's 60 between friends? And then all of a sudden, your test description bears no relevance to all of the asserts that you're doing. So when we do the next test, which is, well, I've posted to the API, let's make sure I get a valid transaction ID back, a valid to-do item ID back. It's another test. But you'll notice that the first 2 lines are the same. What I've done is I've created reusable actions, so creating a brand new test is actually no big thing. Because I've used reusable bits of code, because I'm using a proper language to write these things. And I'm the one that's writing it, me and my team. I'm not having to create step definitions that I pass on to somebody else to use. That was the downfall of BDD, was using those Gherkin syntaxes in order to be able to say, I'll give it to the BAs, and they'll write the test. They never did. Because everyone was, can I have a step definition that does exactly the thing that says in the business requirement? So we end up writing more specific asserts. Another test that describes something and does a thing. Now, when we get to things like persistence, and this is the bit where everybody really goes, yeah, maybe don't do that. Because this is where we start to think about outside in properly. Because if I need to test, and this is a to-do API, everybody should understand a to-do API, there's thousands of them out there. So what they do is they create a to-do item, and then they need to get a to-do item back. If you look at that, add a to-do item with a valid request can be retrieved by the ID. Pretty simple test. This is the point where most engineers, when they're writing tests, will reach around into the database, inject a to-do item, and then hit the get endpoint. And again, that is not how users use your system. If it is, Godspeed. Please tell me where you work so I don't work there again. Ultimately, what they do is they hit your to-do API endpoint, they hit a post, and they post a to-do item, and then they get it back later. Now, if we can mimic that in our test, what we're actually doing is we're testing the whole of our system. We're testing so much more than just what an individual class would do. Because up until this point, you could pretty much just hit a controller class. So what we're doing is, again, a reusable action that makes sense. I don't like the wording of that particular abstraction there, creating a valid to-do item. You could say, create a valid to-do item on the API, or something like that, that makes it descriptive. But then we go and get it, and then we validate that the two IDs are the same. But what have we tested when we did that? Well, we've tested the startup configuration. So we've tested to make sure that we've registered things. Now, how many people in the audience have ran their API in their production environment and it fails with class not registered in dependency injection? Yes, there's about 20% of the room. 80% of you are liars. Because when we write things at a unit test level, we don't use dependency injection, and all our tests pass, so we deploy it. And then it fails because we forgot to register that class in dependency injection, so it doesn't work. When we write things in this way, we're testing the dependency injection, we're testing the routing, we're testing to make sure that a trailing slash works properly. We're also testing serialization and deserialization. Was people in the room around writing software for .NET when Newtonsoft JSON moved to System Text JSON? Because that was a special time for API deserialization. Because there was a lot of subtle changes. But we're testing that. We're testing to make sure that the thing that we post is the thing that we get back in the right formats. Because if we write these tests properly, we don't use the same classes. We don't use the same serialization systems. We write our own classes in the test framework that match what the API should be. Which means, by proxy, we also get contract testing. Because if my test fails, if I've got to change something in my code, my test code, if I've got to change those classes because they don't work anymore, the chances are my consumers are also going to have to change theirs. And if they have to change theirs and you've got 5,000 customers that you can't talk to, you probably need to make sure that you're not going to do that. We've also tested things like model validation. If you've got your own model validators, your model binders, we're testing all of those. We're testing database interactions. In this particular example, it uses Entity Framework under the hood. I'm using the in-memory version of SQLite. I'm testing constraints. I'm testing to make sure we bring back the right columns so it doesn't null them out. Unit tests, if you write them at the method level, generally don't do that. But most importantly, we're testing the customer's APIs, the things that our consumers are going to use, and we're testing the requirements that we've been asked to build. But that's not the end of the story, because there's things that we can't test when we do that. We can't test things where the back end changes, but the front end does not. Caching is a big example of that, because from a consumer's perspective, I just get my data. I don't care whether it comes out of Redis or Valkey, or it comes out of the database. It comes out of Cosmos, it comes out of a SQL server. I don't care. If you have logic that changes, and as long as the data is the same, I'm not going to be able to tell a difference. So we can't test those things. We can't test internal state changes, like I'm writing to an audit log. If that audit log isn't visible outside, I can't test that because I'm on the outside. We can't test performance because, well, we're testing on my machine, and my machine is not production because the database doesn't live on my machine in production. My service bus instance doesn't live on my machine in production. Production is different. We can't test things like cloud services because they introduce latency, and all of a sudden our tests are going to take so much longer to run. We can't test configuration. When you deploy things to production, you're going to have different environment variables for different instances. You're going to have connection strings. You can't test those sort of things in this way. What I'm trying to say here is that there are different gears that you will work in. Working at the outside, you can cover so much more with so much fewer tests. You don't have to test every class with a unit test in your code with XUnit. If they're tested from the outside, their entire behavior is tested, you don't need to. If there is things that it does that you can't test from the outside, then you change gear down. Think about it like a car. If you can run in 6th gear for the entire journey, you're going to get there faster. But sometimes you're going to need to drop down in gears to be able to maneuver quickly. I'm not saying never write unit tests. What I'm saying is you can write so many fewer tests by doing this and cover so much more ground. But ultimately, some of this stuff we can test. And that's where observability comes in. So what is observability? Well, observability has 3 pillars. No, it doesn't. Anybody who knows me knows I love saying 3 pillars. There are no pillars in observability. Essentially, observability comes from control theory. It was from the 1960s. It's around the idea of how do I measure how well the internal states can be inferred from the knowledge of its outputs. That's where the definition comes from. It was co-opted, which is why the 3 pillars is a thing. Ultimately, what we now think about of observability is reliability, availability, quality. Observability is just another characteristic of these systems. But what it allows us to do is be able to infer what's going on inside of that system. That's still what that definition is supposed to mean. And if you go back to what we were talking about these things, these are internal states of the system. Whether we choose a cache, whether it goes into the audit state. Those are internal states of the system. So how can we use observability to understand that? So I want to talk a little bit about something called ODD, or observability during development, observability-driven development, and how we use observability data in order to be able to drive how we write things locally. Because, as I said before, the only environment that matters is production. And the way that we know what's going on in production is using our observability signals. Logs, traces, metrics, events, profiles, exceptions, all of those telemetry signals are what we use in production to understand what's going on. Because observability is an output of our application. Just like the response to an API, observability is an output. You, as an engineer, whether you run your own system or whether somebody else runs it for you, you are a customer of that system. You are a client of that system because the telemetry data is something that you need in order to be able to fix things, in order to be able to understand whether people are having a good experience. Because things like observability can do things that you can't do locally. They can do things like detecting parallelization. Tracing data allows you to be able to see that. It allows you to be able to detect code paths and the usage of your system. Log lines can do that. They can show you that a particular thing was hit because you wrote a log line. But the key characteristic here is what's important to you locally when you're writing your code is probably important in production as well. So let's have a look at some caching code. This is a get list from the to-do API. If there's any potential employers from the future out there, I wouldn't write caching code like this, just to be clear. There are better ways to write caching code. Do not look at this, take a picture of it, and say, this is how Martin said I should implement my caching code on Monday. Please don't. But ultimately, that's the kind of idea. We go and get it from the cache if it exists, otherwise we go and get it from the database. But if we were writing a test, what would we do? Because the output from that API is the same no matter what, whether I got it from the database or I got it from the cache. That's where we can use observability. Now, I have wrote a library called Practical Open. It's a XUnit library that allows you to be able to do this a little bit nicer than this. But we use something called OpenTelemetry. I'm not going to go into what OpenTelemetry is. I've got enough videos on YouTube about that. But we use OpenTelemetry to be able to output what's going on in our system. We use tracing data in this particular example. And what that allows us to be able to do is write something like this. In .NET, we use activity. In other languages, it will be spans. But we can add a little bit of telemetry that lets us know that the database was hit. It'll tell us how long the database connection was. It'll tell us a lot of other things as well. But crucially for what we're talking about today is it will let us know that that particular request we made did make a call to the database. So then in our test, we can have a look at the captured telemetry data and say, well, I hit the API, did you hit the database? And then conversely, we can do the same thing. We can hit the API, we can clear out all the existing telemetry and then say, and then did you hit the database? Nope, good, great. We can use our telemetry data for more than just looking at production. Telemetry data is more than just installing an agent on a machine in production and hoping that it's going to give us insights. Observability is way more than monitoring. Observability is about being intentional about what we need in production. Because production is the environment that matters. I don't care whether you can attach a debugger to your local machine and hit play. I care whether customers are going to use that software and whether customers are having a good experience. And when it goes wrong, I care that you know how it's gone wrong and you can fix it. The best way for you to fix it fast is to have more data, have more context about what was going on and why. If we can take that and start using it locally, it is so much better. Everybody's probably heard like 17 presentations on Aspire this week. Ultimately, what Aspire is really good at is evangelizing that telemetry is a thing that you should care about. If you can take this data, I forgot to put this slide in, but you can then refactor for readability. If you can take that data and start being able to see what's going on locally, it's great. I did a workshop for a couple of days this week. Something that was really big that came out of it was the people who were writing this code were like, that telemetry doesn't look right. That was their local machine. It's like, I'm looking at the trace data, and it doesn't look right. That span finishes before the other span starts. That doesn't look right. Turns out they were disposing of it too soon. But they were using that telemetry data as a barometer to know whether they knew what was going on, because that's important in production as well. Now, a few do's and don'ts. Do use this for things that you care about in production. If you're never going to care about it in production, don't bother with this stuff. Test things that are important. Don't test things that don't matter. Don't test things that are unimportant. Make sure that you have good data. Make sure that you have data that is valuable on your tracing data, on your logging data, on your metrics data. Make sure that's valuable. Add more data when it makes sense. I know that my example said check the database was called. Don't do that in a production scenario. I did that because people will understand what it means. Don't check the database was called, and don't check a method was called. Those things don't matter. The end user doesn't care that you hit a database, that you hit Cosmos versus hitting SQL. They don't care that it hit a cache versus not hitting a cache, really. But that might be a functional requirement that you do care about. Now, final thing I want to talk about is using tracing as a test artifact. Now, I wrote a framework called XUnit OpenTelemetry, which allows you to add something like this into XUnit. And what that will do is it will trace every test that you write. And if you're writing your tests in this particular way, or even if you're not and you're just writing in testing classes that do use observability data like tracing and metrics and logs, God forbid, it will allow you to be able to take that data and use it really quickly. But it will allow you to be able to do things like this. You can run your test, and you can see what the trace would look like. You can see what the metrics will look like. You can throw that data into Aspire locally and see what it looks like. What that allows you to do is that when you go to production and you get an email that says, Dave said he's having a problem, and I've got the trace for you, you can take that trace and you can find a test that matches that requirement. And you can put the two together and say, these don't look the same. Why do they not look the same? Because you're using the same tools. Using the same tool locally as you're using in production. You can look at this kind of stuff and go, but that still hits the database. You can look at that and go, why doesn't that hit service bus twice? Why doesn't that make a call to this other service? You can use this inside of those frameworks to be able to see what's going on. You can then do things like be able to see how your telemetry is changing over time. You can graph all of this data that you're getting. You can take the tags off your tests and be able to do analytics around them. You don't have to use the inbuilt tools from TeamCity and CircleCI and be able to produce reports out of GitHub because it doesn't give you this kind of criteria anymore. You can use your observability tooling to do that by using standard OpenTelemetry data. So how do we be better? There's a few things I want you to take away from this talk. Think about what gear you are in. It's not about saying always right at the outside. It's about choosing the right gear for the thing that you're doing. Am I trying to go fast and the things I can test from the outside, then do the outside? If you can't, should I move down gears? If I'm moving down gears, should I move back up again afterwards? Think about what gear you're in and whether that's the right gear for the thing that you're trying to do. Write tests that matter. If you feel like you're writing a test that doesn't matter, it probably doesn't. Think about it. If it doesn't matter, don't do it. Don't waste your time. Nobody cares about those 4,000 unit tests. I know you're proud of them. I'm proud of you too. Don't make your applications brittle. Don't make your software brittle. Remember, software is not just the thing you put on GitHub and then you deploy to an EC2 instance or an Azure VM or container apps. Software is all of it. Do not make that software brittle by writing tests that are too low when you don't need to. And think about your requirements first. A few things for you to take away. You can take a picture of this if you want to. This is the resources bit. The repository is up there. I'm going to push up an update later on today, maybe tomorrow, that'll have some of the new stuff in there. A couple of follow-on talks if you want to go away and have a think. There's a guy called Ian Cooper who did TDD Revisited. I cannot recommend that talk enough. It breaks down TDD into what it was, what it should be. It will reform your brain on what TDD is about. I talk about writing tests, writing them better, making them readable, There's a talk by David Whitney who talks about how we write better tests, or more specifically, how we write tests that do not suck. The people who send me to this conference for you to come and listen to me are Honeycomb. We have a free account that you can use forever, no credit card required, that you can send all of this data to. Please go and sign up. If you don't like me, then obviously don't. That will show them. We also literally wrote the book on observability engineering. It is free on our website. We talk about a lot of these concepts around observability and observability-driven development, that kind of stuff. It doesn't talk about Honeycomb. It's around observability engineering. It's a free O'Reilly book. Go check it out. But on that note, I will be around for questions, and please try and think about the fact that this is hard to do, but are you too busy to improve? Thank you very much.